Okay, so we'll deal with set operations. In set operations, we have four kinds: union, intersection, difference, and complement. Now, for union, the definition of union is to combine all elements of the mode set. So, if we have A union B, we are going to simply combine the elements of A and B. So, that would be 1, 2, 3, union 2, 4. So if we're going to write the elements, that would be 1, 2, 3, 4. Again, let me repeat from our previous video. I have said that even if the elements are listed more than once, you are going to list them only once on the final answer. So we have two 2's in our final answer. We only write it once. Okay. So that is union. You just combine. Let's try one more. Let's say B union C. So that would be 2, 4 union 1, 3, 5, giving us 1, 2, 3, 4, 5. Or you can write it as 2, 4, 1, 3, 5. It doesn't matter. But this is more pleasing to look at. So we have rearranged the units. Okay, intersection. When we say intersection, you choose what is common. So let's say A intersection B. A is 1, 2, 3. B is 2, 4. What is common between A and B? The answer is 2. So our answer is simply 2. How about A intersection C? A intersection C. 1, 2, 3. Intersection 1, 3, 5. 1 is common. 2, no. 3, yes. 5, no. So the answer is 1, 3. So what if we have B intersection B? B is 2, 4. D is 3. Do you have elements in common? None. So the answer is empty. Alright. Difference. When we say difference, we remove what is common and we are left with what is left of the first set. So in intersection, we choose what is common. In difference, we remove what is common. So A minus B. So 1, 2, 3 minus 2, 4. 1, okay, it's not common, so we copy 1. 2 is common, we remove. 3, it's not common, so it's okay. So we are left with 1 and 3. Again, what is left of the first set? Never mind what is left of the second set. Okay, our answer for A minus B will only be based on what is left of the first set. So A minus B is different from B minus A. So B minus A, I have 2, 4 minus 1, 2, 3. 2 is common. What is left? 4. So our answer is 4. What about complement? Complement is similar to difference in such that instead of having two sets, our first set will always be the universal set. Okay? So if we have a complement, that is the same as U minus A, which is, in our case, U is 1 to 5, minus 1, 2, 3. So 1, 2, 3. What is left? 4 and 5. Okay. So what about D complement? D complement, we can use prime, let's just say we use C here. B complement, so that is U minus B. It is 1, 2, 3, 4, 5 minus 3. So if we remove 3, what's left? 1, 2, 4, 5. So those are the 4 basic set operations. Okay, so we have Venn diagrams. Now Venn diagrams are used to illustrate sets using diagrams, or the relationship between sets using squares and circles, although we can use other shapes, but rectangles and squares are the easiest one to draw. So if we have this, let's say we have here two sets. We have set A and set B. Do take note that the sets are connected, meaning there are common elements between the sets if you draw it this way. But if you draw it this way, let's just say we have it here for the meantime. 1, 2, this is a set A, this is set B. It means there are no common elements between A and B. So the box represents the rest of your universal set. Whatever is not included in A and B are in your universal set, so we have a box outside. Union, as with the definition of union in our previous video, that you combine all elements of A and B. So A union B, you are going to shape all A and B. So both A and B, both circles for A and B. Intersection, what is common between A and B? So it is this part. That's why we're going to shape this region only. Difference. What is left when we remove what is common? What is common? This part. What is left? This part. Okay, so this is A exclusive. Complement, well, everything outside of A. So that includes some parts of B and then the box. So that's how we perform operations on Venn diagrams. Now, take a look at this problem. We have A minus B intersection C, and then we take its complement. Now, the problem might look scary at first because of multiple sets and operations, but we're going to break it down part by part. We start with A minus B. This is A, and this is B. So, again, A minus B, we disregard the commonality of A and B, and then we just get what is exclusive of A. So we have here 4 regions, 1, 2, 3, and 4. Between A and B, the common regions are 3 and 4. A is exclusive, 1 and 2 are not included in B. We have here A minus B. Disregard C for a meantime. So 1 and 2. This region, A minus B, represents regions 1 and 2. So we lightly shade it for the meantime. Let's proceed. Remove this. Okay. Now, intersection C. So if we number, this was 3 and then 4. If we number this 5 and 6, region number 5, region number 6. C contains the regions 2, 4, 5, and 6. A minus B contains the regions 1 and 2. Now it says here, this intersection with C. So what is common between A minus B and then C? We can see here that the common region is only 2. So we remove the shade here. We don't need that anymore. Right? So this would be the shaded region if we consider this. Now, we have one final operation, which is complement. Everything outside of this. This problem, or this part of the problem, only considers 2, region number 2. So if we're going to take everything outside of 2, we're going to shape everything except 2. You don't have to fully shape it, you can just use this. everything is shaded except this region. So this is the representation of this. Alright, this is another application of Venn diagrams. So we have here a problem on the enrollment of students. We are trying to determine how many are enrolled in MMW only, how many are enrolled in pre-cal only, and how many are not enrolled in the two subjects. So given the data, there are 100 enrolled students, 50 enrolled in MMW, 35 enrolled in pre-cal, and 25 enrolled in both MMW and pre-cal. Now, the problem here is, how do we distribute the students? Take note, this circle represents all students enrolled in MMW. This one represents all enrolled in pre-calculus. You cannot simply write 35 and then 50 here and then 15 here to denote the number of students, because, take note, what about this region? How many are in this? So the trick in solving these kinds of problems is to start in the middle or in the intersection. According to our data, 25 are enrolled in both MMW and pre-cal. So MMW, pre-cal, both MMW and pre-cal. So we have here 25 students. Now, let's go to the next one. 35 are enrolled in pre-calculus. This whole circle represents those who are enrolled in pre-calculus. We already have 25 who are enrolled in both. So 35 minus 25 means we have 10 students enrolled in pre-calculus only. And then here, 50 minus 25 again, 25. So 25 are enrolled in MMW only. How many are not enrolled in the two subjects? So 25 plus 25, 50 plus 10, 60, meaning there are 40 students not enrolled in both MMW and pre-cal. Okay. So let's check questions. Pre-cal only, we have 10. MMW only, we have 25. Not enrolled in any of the two, we have 4. Right? So that's it. I'll see you in the next video.